First, we will give a short, brief introduction to Docker, and then we will define our sample web app. Because the topic today is to ship a Python project by Docker, so we need to build a very, very simple web app, and it is based on Flask. And third, we will talk about how to build and run a Docker image. And then the fourth, we will talk about Docker index. It's kind of a GitHub for the Docker image. I think it will be a game changer for the deployment. The last thing, we will talk about how to deploy our Docker image to AWS. Let's think in the very beginning. And there are a lot of software stack today. We have a lot of static website generator. We have a lot of web framework, such like Rails, Django. We have the MongoDB. We have MySQL. We have a lot of message queue, so many software stack, and we want to deploy to our own laptop. We want to deploy our friend's laptop. We want to deploy to the Amazon. We want to deploy to the QS server. So we will get this matrix. There's so many kind of the software stack, and we want to deploy to so many kind of the server. Before Docker, we have to write a lot of script to deploy each software stack to whatever we want to deploy. If you want to deploy the Django web framework to Amazon, you want to write a script to deploy your Amazon. And if you want to deploy your QA server, you have to write another script to deploy to your QA server. So there are a lot of scripts we need to write. And think about when we were in the 1960s. There are a lot of the things we need to deploy. We have cars, we have piano, we have coffee beans. We want to ship our product by the truck, by the ship, by the chain. So how do we solve this question? And at that time, we introduced the intermodal shipping container. We can, the manufacturer of the cars or the piano will pack their product into the container, and the people know how to put their container into their truck and the train or their ship. But it is for the physical product. But how about software product? The Docker index is to help you to pack your software stack. You can pack your Django web framework. You can pack your MongoDB. You can pack whatever you want to pack, and you can deploy this container to everywhere you want to deploy. You can first install the Docker in the Amazon. You can install the Docker in your own laptop. You can install your Docker image into your friend's laptop. So everything becomes very easy if we have the Docker index, if we have the Docker container. So the metric will become very easy. We only need to know how to build a Docker image, and we only need to know, and we need to know how to ship our Docker image to our server. But you might think we already have the VM. Why do we still need the container? The difference between the virtual machine and the container is that virtual machine need to run its own virtual OS, but the container don't need to run the OS. Think about you want to run 10 apps in your server, and you need to, if you use the virtual machine, you need to run extra 10 OS there. But if you use the container, all of the container run the same OS, the original OS. So it has the much less overhead. So let's talk about how to install Docker. You might think it's very hard, but in fact it's very easy in a modern Linux distribution. For example, the last version of Ubuntu, you only need to update your package manager and then install Docker IO. And the last one is to make a link the Docker command to a Docker IO, so you can easily type the Docker instead of the Docker IO. And the first thing we need to do is to pull the best image. Think about you are using the virtual machine. The first thing you need to do is to download the virtual machine image from the website, so that you can do other things. So you can use the VirtualBox or virtual VMware to open this image and then do the things you want to do. And in Docker, we also need this best image, and things become very easy if we use Docker. We only need to type the Docker pull and the image we want to pull. And the Ubuntu image is provided by Docker officially, so we just can type the Docker pull Ubuntu. Then you can get a lot of image here. And to see how many images we have now, we can type the Docker image. Then we can see that we now have a lot of Ubuntu image now. So how do we run the command we want to run in those images? We just need to type the Docker run and the image name and the command we want to execute. For example, if we want to list the files under the root directory in our Docker image, we just need to type Docker run Ubuntu ls-l/root. Then the following files are the files in our Docker image. So the goal today is to install the Flask App into the Docker image and then run this Flask App. And I have already write a simple Flask App sample, and I have already push it into the GitHub, and there are some files in my repository. The first is the app.py. It is a Flask app, and if you are not familiar with the Flask, you can think it is an app listen to the port 4000 and return the hello world. It's a very simple web app. And the next thing, we need the requirements to teach the Python package management that what package we need to install. The only thing we need to install is the Flask. And first we talk about how to install the Flask app in our computer locally. The things we need to do is first to install the Python setup tools, and then we will have the easy install, and we will use the easy install to install the PIP, and then use the PIP to install the dependency which is listed on the requirements. After all, we can execute the Python app, our Flask app app.py, and then the server will run in the background, and which is listened to the 4000 port. And this is the way to run the Flask app in our computer directly. And how about the Docker? To run the Docker, we need to pack the Flask app into a container. So we need to build an image to include the Flask app. And the way to build an image, we can use the Dockerfile. It is a file to teach the Docker how to build a Docker image. And it's very simple, it's just like what we did before. The first line is to tell the Docker that we need to base on a best image, and it's just like the Docker pull Ubuntu. The image we want to build is based on the Ubuntu, so you don't need to provide other things. And after you pull the Ubuntu, you need to tell the Docker what command you want to install based on your Ubuntu image. The first thing is to install the Python setup tool, just we mentioned before, and then install the PIP. And the third thing is the difference, because the requirements is located in your local computer now, and we would like to add these requirements into your Docker image, and then you can install the requirements. So we use the commands add add the requirements.txt to the source requirements.txt. The first parameter is the location of the requirements in your own computer, and the second parameter is the requirements, is the destination you want to put in your Docker image. And after you add these requirements, you can use the pip install to install the requirements. And then you need to add your Flask App into the Docker image. We use the add doc/src. And then you need to export the port you want to export, because outside the Docker image, they don't know how to link to your website. You need to have a port forwarding to map the port. So the export 5,000 means that the Docker image will export its 5,000 port. And last thing is to mention the command we want to run. And the difference between the run and the command is that the run command, run is, and the Docker will execute the run command when the Docker build the image, and the cmd is to use when we run the image. I will mention that later. So how to build an image? We simply use the Docker build. The -t means that we give an image a name and tell the Docker the path of the Dockerfile. So we do the Docker build -t, and we name it my app. And then don't forget the dot here. This means the path to the Dockerfile. And then we will see the Docker will start to build your image, and you will see the first step is from Ubuntu, and then apt-get install Python setup tools, and finally you will get a new image, and you can use the Docker image to check the new image, and then we will see the new image. My app is here. And how do we run this app? Do you remember that we can use the Docker run to run the image? But here we need to add some parameter. We need to add -d, because we don't want to get stuck in the command, because it is our app will run forever. We need to detach it, and then we need to do the port forwarding things. And the different thing is that we don't need to give it the command we want to execute, because we have mentioned that the command we want to run is the Python source /app.py. So we don't need to tell Docker what to run here. But of course, you can override the command we store in the Dockerfile. After running a Docker process, we can use the Docker PS to check, just like the PS in your Linux environment. We can use the Docker PS to check how many Docker processes are running now. And to kill this process, we simply use the Docker kill and append the container ID, and the process will be killed. Let's have a short demonstration. And this is a repository I download from the GitHub. And this is the same Dockerfile, same as we just mentioned. And then we use the Docker build and add the image name. And because I have already built it before, so something have been cached, so it's very fast. And when you run it, you need to some time to wait it to to do the PIP things. And after you build a Docker image, you will have the myapp, and you can run it by because I have already run it before, so we now have a container. It is now a running Docker process here, and then we can try to link our Flask app. And it just return the hello world, so it works. Then we will kill the Docker process. Then we kill the Docker process by its container ID, and we only need to type the first few letters. Then we killed it. It has been killed now. And let's talk about Docker index. It is kind of the GitHub for the Docker image. Sorry, and you can pull a lot of image from the Docker index. You can pull the MySQL, you can pull the MongoDB, you can pull the Hadoop. Probably you can pull anything you want. You just need to search the MongoDB from the Docker index. Then somebody have already built a MongoDB. So what you only need to do is you just need to for example, if you want to build a MongoDB, and you can type MongoDB here. And somebody have already built a MongoDB image. You just need to Docker pull Dockerfile MongoDB, and you can Docker run this MongoDB. You don't need to install the MongoDB in your own computer anymore. And one more interesting thing is that you can create an account in the Docker index and open a repository in the Docker index and hook this repository onto your GitHub repository. And then once you push to your GitHub, and the Docker index will help you to build a Docker image automatically. For example, this is my Docker index account. And I can add a new repository. And because I have already logged in my GitHub account, so I can find my GitHub repository. So that's it. We just need to select it, and and give it a name. And because I have already built one before, so I used another name here, and then create a repository. Now the Docker index is building your image, and then you can use it directly after it finished. I used the one before. This is the one I built yesterday, and after it finished, I only need to do the Docker pull. Then I can get my image. So if you want to deploy it to Amazon, you just need to first connect to the Amazon and copy these Docker pool things, and you will start to pull the data, to pull the image, and then you can run it just like we run it in our local machine. Okay. So now it works on the Amazon. So in the future, you only need to push to your GitHub and then hook the account to the Docker index. Then the Docker index will automatically help you to build this image. And then you can also, in the future, you can also hook your Docker index account to your CI server, your QA server, your staging server, your production server. Then once you push it to your GitHub, all the things will be deployed automatically. So you just need to log in your production server by whatever you want. You can use SSH, you can use Fabric, you can use Caps Channel, you can use Chef, you can use Puppet, anything you want. And then do the following things. The first is to pull the image, and the second is to run it directly. Okay. So, and I have prepared some gift. If you ask me a question. This is a T-shirt sponsored by the Docker, officially. So you ask me first.
Yeah, I have a question about. I have several questions actually. So the first one is like, what's the difference between image and container? Is it the same?
Okay. You can think the image as the program and the container as the process.
Okay.
If we build an image, when we run the image, it's called a container.
Okay. Okay, I see. So it's like an image is the thing on the disk, and container is actually
running in your memory.
Another question is like, you can expose certain port,
yes,
but
yes.
When you put the container onto the, for example, the cloud,
yeah.
then several people would share because like a container is like actually like a program on a certain virtual machine or something like that,
yeah.
on certain OS or something like that. So there would be several containers on the same machine.
Yeah.
And then when you expose the same port, for example, like several
yeah.
containers expose the same port, like 5,000 or something like that, you will cause some problem, right?
We can, because the first parameter here is the port in your local computer, and the next one is the port in your Docker image. So if you have the next image, you can use the porting to port your say 4,000 to the 5,000 port in your Docker image.
So that means that other people will not share the same computer with you, right?
Yeah.
So you have
you can just use the different port to port.
Okay. I see.
Thank you for your talk. I understand that the Docker index is the image index is accessible from it's open to the world. So is there any way? So for example, if we have a production environment and we want to keep our image private, is there any way to have your own private image index?
Yes, it now have just like GitHub. the open repository is free, and if you want to have your private repository, you need to pay.
Thank you.
So what is your opinion about the configuration-based deployment for, like Fig that's used with Docker? I mean, what do you prefer as ways to improve deployment with Docker?
Do you mean about the configuration?
Because right now we're using Fig to deploy Docker containers. Fig, it's a Python application that lets you define YAML files to define your containers. So, do you have other suggestions with regards to deploying Docker containers?
And at this moment, there are a lot of companies building the ecosystem for Docker. And I think, for example, you might find the Docker in Docker CI. And and they already have a lot of the service about based on the Docker. So I think in the future, those services can hook onto your Docker index repository. So once you push to your GitHub, and then Docker index will rebuild the image, and then send the image to your CI server, to your quality assurance server.
Okay.
And then I prefer this way.
Okay. Thank you.
Any more questions? One more. Okay.
What's the difference between the LXC and the Docker?
And in fact, the Docker is based on the LXC. Okay.
So
They are all container based, and the powerful of the Docker is ecosystem.
Any question more? Please.
How do your application configuration file in your local file system?
Lots of people are using the etcd to, it's kind of a zookeeper. It is a distributed configuration server. So maybe you can take a look at this. And the core OS is a new Linux distribution, and it used the Docker as before, and use the etcd as the configuration server. So you can easily to put the configuration into your Docker image by etcd.
So that already integrated or always integrated Docker?
There are some open source software to help you to do this thing. The first is the Fleet. It helps you to. Let's talk about another one. It is a Heroku like PaaS, and it is open source. So you can install the FRIR in your server, and then you just need to push the prompt file. It's the same with the Heroku, and the configuration file. You just need to put your configuration file in this file, and then everything will run successfully. You can take a look at this.
Okay, everyone, we have timed up, and let's thank the speaker again.